So we have about maybe 10 minutes here before lunch to take some questions. See any questions for the speakers?
Yeah. Hello. Yes. How well do standards address the high levels of customization that people have in their CAD and PLM environments? And, you know, are there standards for deployment of technology as well as the file format?
Yeah, that's an interesting question, because if you look at the evolution, the CAD part has become much more commoditized over the last 30 or 40 years. We still have the requirement to have a common language for PLM systems, and when you customize your system, you're making your own dialect, if you like. So part of the challenge for the industry sectors is to reach as much of common agreement as they can over what is the lingua franca that they can use. Standards will help, but we can actually see solutions in industry where you can develop an arbitrary large degree of non-interoperability through your own customization. You have to make a balancing act between your internal business processes and your external processes, because non-optimization in each of those areas will produce cost. So you need to balance it out so that you can operate effectively across the whole of your supply network. And I don't think that's feasible to do at a global level. It's probable that it can be done at an industry level, and the evidence, the empirical evidence we have from aerospace is that we can do that. But you're right, it's a challenge. You can break a standard much more easily than you can successfully implement it.
Just to add the need of leadership on this. Who is going to take the lead? I agree that, with my colleague that there's the need that each industry has their own standards, because it will be very difficult to make different industries to have the same standards. But in each industry, we have to see who is the one to take the lead. For example, in the automotive industry, we think the OEMs are the ones that can have more position or vision to take the lead to create certain standards.
I think I'm going to be the heretic in the room, because technology will always lead standardization, right? And what's happening now is we're on this exponential curve of technology that is advancing beyond the pace which our brains can even understand. A good story that came out recently about this is with Google's image search. So they have deep learning algorithms that they're using to recognize what is in an image. And they don't teach it what a cat looks like. They feed it millions of images, and the machine figures out what is significant in that image and creates its own algorithms for image recognition, and is now performing at a level beyond what the original developers had anticipated. And the only way that they can tell you why it's performing that well is to reverse engineer the code that the machine generated. So in that kind of environment, how would you create the standards of an image, or what is a cat, or what is anything? And we're fast approaching that in the three-dimensional design space, in the CAD space. Again, when we get to algorithmic generation of these designs, where these designs are so complex that we can't reverse engineer it easily, what are the standards for that world? Again, what are the standards for a world in which every material is bespoke? And I think there's a precedent for it. It's called physics, right? Our scientists are trying to figure out the laws of physics which govern the standards of everything around us. So ultimately, if you want to get down to the smallest element, it is how two atoms interact, and that dictates the standards of everything around us. So I'm almost thinking, instead of standards trying to keep up with technology as it evolves, why don't we just put the stop at some point as the interaction of molecules and try to figure that one out, which is going to last a lot longer than coming up with a new step file or new CAD formats, which are going to be outmoded as soon as you put a standard on it.
That's certainly an interesting view, and I would make the comment that rather than sending petabytes of data to do your pet cat as a model, you probably need to send something that can be interpreted at the end device in a consistent manner, which would be a higher level model of some sort. But yeah, it's a real challenge to keep the standards up to date. One of the issues we have at the moment that after probably 3,000 years of development of the engineering drawing, they're coming out with some new extensions to apply some new meanings on the drawings, and those will have to be incorporated in the standard. The only way we can address that is by working in close collaboration with those who are making the changes, and use that to get the product definitions over to the new set of devices. When we're working down at the molecular level, in some way that information is going to need to be represented.
Thank you. I think we have time for one more question before lunch. Yes.
Yes. I just have a remark. For your information, I am an AutoDesk partner also. And what is interesting, maybe you do not know, but for years we have working in the international group for developing what we call the Step NC data structure. And this Step NC data structure is aiming at integrating the design from the CAD or PLM with the manufacturing technology. And we are extending this format also today for the additive manufacturing, because today you are using the STL format. And the STL is has many shortcomings. For example, for the color you are talking about, we need to extend this step format in order to promote this standardization.
The problem is, again, step is just a boundary representation, so it's an analytical surface that contains a solid. So it's very hard to teach a step to know functionally graded materials, where every material inside of that volume is different. So one way to do it is to break down the step files into smaller and smaller volumes. The problem is the data sizes, again, get unmanageable when you go that route. So in my opinion, step is not going to be the way forward for multi-material additive. And then adding to that with the Step NC program, now you have to think about how do you plan tool paths when you're adding and subtracting all within the same machine. It adds a few more dimensions of complexity to your toolpath generation.
Another information, in fact, it's not step in the cell because the step is a static data structure. We mainly use express language. And in that case, like XML, you can describe whatever you want. It's object-oriented. But the problem today, we have a lot of additional features in the machine tool industry, and these additional features are proprietary, described by proprietary format. That is the reason. So it's a problem of the market.
I would make one comment there, just on a point of factual accuracy, that step is not just BREP. You have solid geometries in there to which you can apply material properties. Now the challenge, and I think that's, as I mentioned, a challenge for any of the new innovations, is what's the best way to do that representation in terms of, because we can do multiple materials. When you're doing a variation of material property, that may well require a different approach. But that's why we need to plan standards development, so that when you get the requirement, then hopefully here's one we prepared earlier.
Okay, I think that takes us up to the lunch break. I'd like to thank all of our speakers. I think that was a very interesting set of presentations.